In this video, I discussed the process we used in developing norms for EasyCBM. New norms were developed for EasyCBM during the 2013-2014 school year to better represent reading and mathematics performance across the nation. Previous norms were based on all students taking the measures at any grade and benchmark season, fall, winter, and spring. Therefore, the scores didn't necessarily reflect the demographics of specific regions and student characteristics, for example, race, ethnicity, and gender. In conducting an analysis of the user base, these students were predominantly from the West and white. Therefore, to provide a more comparable base of students in the United States, new norms were developed using a stratified random sample of students that reflected the children attending schools proportionate to their demographics, region, and race, ethnicity, gender. We used the most recent Common Core data, 2010-2011, published by the National Center on Education Statistics, to first determine the counts and percentages of students in regions as well as by gender and race ethnicity, and then sampled accordingly. The norms were developed with a fixed group of 500 students to represent each region and race, ethnicity, gender group. This sample size was determined to be optimal in capturing the largest and most stable group of students with scores on the various measures. When fewer students were present, we weighted the population to reflect 500. When we developed the norms for EasyCBM, we completed a number of steps to ensure that the sampling was stratified according to the Common Core data set 2011 and 12. We first started by associating each state with a region because we wanted to have region representation that was equal with 500 students per region. And this is the table of which state went into which region. We also categorized students from the data set as to their grade level, their ethnicity and race, and their gender, and these are the codes that we used. We then counted in this database the number of students in each of these variables, region or ethnicity, race, and gender, and calculated the percentage. So you can see the values as an example from kindergarten for students in the data set. We wanted to proportionally sample so that we had 500 per variable, 500 per region, or 500 per ethnicity and race and gender. So within each region, we calculated the number of students that needed to be proportionate, assuming 500 in each group and 2,000 overall. At this point, we needed to go back to our user database and find out how many students were in each measure at each time period for each region and for each ethnicity and race and gender variable. So here's an example where we went into our database and we know we want 500 from each of the 4 regions. And in the third column over, you can see how many we have. And clearly the West has the most students across the regions and barely 500 in the Northeast. So we needed to take only 4% of those from the West, but we needed to take 96% of those from the Northeast so that we could end up with 500 in each of the regions. We did the same thing with demographic variables. So you see 4 categories: white male, white female, non-white male, non-white female. We know we need 500 in each of these groups. We have a couple thousand white male and female and roughly 1,300 non-white male and female. So we could get by with sampling 22% or so from the white male and females and needed 38 to 39% for the non-white males and females. This is an example of the results as we've displayed them in tables that are available on the resources page from EasyCBM. You see for each region a series of percentile ranks at the 5th, 10th, 15th, etc. And generally you'll see there's a significant and steady improvement in performance over time. Over the percentile ranks. You will see it over time from the fall to the winter to the spring. You also see differences among different student groups whites, non-whites, males, and females, and we can be sure that these differences are not a function of overrepresentation. In fact, each of the variables has 500 per group. This is another way that we display our data. In this case, rather than percentile ranks, we use averages and standard deviations. The average is the same as the mean, and the standard deviation is a measure of variation. So you see 500 students. We were just a couple shy in 2 regions, but basically there are very similar averages and standard deviations. You do see some differences among the student groups, with females, white females outperforming the other 3 groups. And the lowest performing group is non-white males. Comparable variation in the standard deviation. The nationally representative norms on EasyCBM represent a significant improvement over less stringent norm sampling approaches. A detailed technical report with all subgroup norm values displayed can be found on the BRT Project's website.